Okay, let's take a look at section 13.3, angles and polygons. This lesson is going to be about figuring out the inside angles, known as the interior angles, the total and an individual one, as well as the exterior angles. So before we actually jump into the lesson, I'm going to direct your attention over to here, and let's take a look at some patterns. Let's take a look at a few common shapes. We'll take a triangle, a square, a pentagon, 5 sides, and we'll stop at a hexagon, 6 sides. Okay, we're just going to make like a little chart, a few things. Now to start out with, our goal is going to be to figure out how many degrees are on the inside. How many total degrees there are inside a figure. Now a triangle, we know there's 180 degrees. Now you may know that a rectangle or a square is 360 because each angle is 90. So 90 plus 90 plus 90 plus 90, or 90 times 4 is 360 degrees. But do you know what about a pentagon, 5 sides? Or do you know how many degrees are in a hexagon, or a heptagon, or an octagon, or all the way up? Do you know how many degrees are in a 50-sided figure? That's what we're trying to figure out, how many total degrees are on the inside. And it depends how many sides you have that's going to change it. So let's go ahead and figure it out. One way we could do this would be to like memorize, like the beginning ones like we have here, and then just memorize the rest of them. Another way is a trick using triangles. So let's base it off of what we know. I'm going to make a few rows here. This first one is going to represent our number of sides. Then we're going to have our number of triangles, and you'll see what I mean in a second. And then we'll list our total interior degrees, so the ones on the inside. So we'll make 3 rows here. Okay, so the first one, the number of sides that we have, there are 3 sides to this triangle, and there's only one triangle that's formed. And we know there's 180 total degrees on the inside. So that one's a given. Triangles aren't that exciting because we already know that, so we're not really solving for anything there. A square or a rectangle, either one, has 4 sides. Now, in terms of number of triangles, what we can do is if we pick one of the vertices, one vertex, and we connect it to each of the other vertex or vertices, so we connect it to this point, and this point. Oh, how many triangles do we end up with? We end up with 1 triangle here, 1 triangle here. So it's 2 triangles. If each of them are 180 degrees, what's 180 plus 180? 360. So what we see here is when we have 2 triangles, we get 360 degrees. Let's go to this third one. 5 sides here. We're going to connect each endpoint to another endpoint, each vertice to another vertice or vertex. So we end up with 1, 2, 3 triangles, because that line is really like that. 3 triangles. 3, we know each of them is 180, so 3 times 180 is 540. There's 540 degrees in a pentagon. Then let's try a hexagon. We have 6 sides. We're going to connect it to each of the corners, each of our vertices, rather, not endpoints, vertices. We get 1, 2, 3, 4 triangles. Then we see how many total degrees that would be. Well, we know that each triangle is 180 degrees, so 180 times 4, 720. Now we could keep doing this. We see that all we have to do is break it into triangles. That's a method of figuring out how many degrees are on the inside. But what happens if I ask you to draw or find out how many total interior degrees there are in a 25-gon, meaning there's 25 sides? Can you draw a 25-gon? That would be drawing like 1, 2, 3, 4, 5, 6. And you need to get 25. I don't know about you, but I can't really see the angles there. And we can't do something like this, because that's concave. We don't want a concave figure. We want all of them to be convex. Notice how they're all stepping out. So what we're going to look at is a pattern. I want you to notice between this row here and this row here, any relationship between the number of sides and the number of triangles. You should be looking and seeing, oh, 3 minus 2 is 1. 4 minus 2 is 2. We have whatever number of sides we have. If we subtract that by 2, we end up with how many triangles we have. So if there's 6 sides, we subtract it by 2, we find out that there's 4 triangles. This would work for anything. If there's 100 sides to our polygon, we subtract it by 2, would have 98 triangles. And how does that help us? Well, if we know that each triangle is 180 degrees, when we know how many triangles we have, we just multiply it by 180. So this is what we end up coming up with. We end up finding that all we have to do is take the number of sides, subtract 2 from that, and that will tell us how many triangles we get, and then we multiply that by 180. And that, ladies and gentlemen, is how you find the sum of the measures of the interior angles of a polygon. You're going to do n minus 2. We'll let n equal the number of sides, and then multiply that times 180. Multiply that by 180 because 180 is how many degrees are in each triangle. So this n minus 2 really is our number of sides minus 2. It really is telling us the number of triangles we have. And we know each triangle is 180, so all we have to do then is multiply the number of triangles by 180, and there's our answer. That's going to give us the sum, so that's the total interior degrees. Okay? So, one last thing, and then we're going to move on to problem solving. The measure of an interior angle. If I just want one angle, I know there's 540 degrees in all of that. Let me cover all of this. We're going to kind of clear our slate for the moment. If I have a regular pentagon, if it's regular, that means all of my sides are the same, all of my angles are the same. If I have a regular pentagon, now we just did it and I found out there's 540 degrees total on the inside. If I want to know just one of them, and they're all the same, all I have to do is take that answer and divide by 5. If I have a regular hexagon, 6 sides, so they're all the same angle, and all of my sides are the same, and I know that there's a total of 720 degrees, all I have to do is 720 divided by 6, because there's 6 angles. If I had a heptagon, I could keep doing this, 3, 4, 5, 6, 7. That's not a regular one, so we'll scratch that. But that's all you have to do. If we have like a square or a rectangle, and I know there's 360 degrees, all I do is take that 360 and divide it by 4 to find out one angle, which is why we end up getting a right angle, because it's equal to 90. So for the second part, if they just want an interior angle, you're going to do the same formula, n minus 2 times 180, and then you could get your answer, and then divide that by how many sides you have. Here we had 5 sides, so we divided by 5. Here we had 6 sides, we divided by 6. 4 sides, divide by 4. So you divide by how many sides you have. Again, n is equal to your number of sides. Okay? Good job. Stick around for the next one. We'll do some actual practice ones when we dive into examples 1 and 2 and 3 and all the rest.